Hey everyone, and welcome to your C++ tutorial on arrays. So let's begin by creating a quick definition of what an array is. So an array is a collection of elements identified by an index, right? So you can think of an array as sort of like a list, and you can think of maybe like a grocery list. You have like apples, pears, bread, eggs, whatever. But each of those elements is identified by an index or it's identified by a number. So let's create a list right now. And let's call this will be a list of the Chicago Bulls championships. Championship years. So the Chicago Bulls won championships in 1991, 1992, 1993, 1994, I believe. Or no, sorry, they didn't get 1994. They got 96, 1997, and 1998. So this is a list of the Chicago Bulls championship years. Now, conceptually, to make this an array, we would need to assign an index to each of these elements. So arrays always start at 0. So the first element is identified by a 0 and not a 1. And this is true for most languages, right? So we start the array at 0 for our first element, and then we go through. We have 1 for our second, 2 for our third, and so on. So I'll just continue on through here. And once I get to the end, you'll notice that we end in a 5. So there's 6 elements in the array, but we end on the fifth within an index of 5 because we started at 0. So now conceptually, this is an array, right? We have our elements here, and each element is identified by an index. Awesome. Okay, so now let's take a look at the C++ syntax for creating an array. So we're going to keep it the same. Here, we're going to do the Chicago Bulls championship years. And since each year is a number, we're going to use integers for the type of the array. So when you create an array, you have to tell the compiler what type of elements you're going to be putting into the array. So we're going to be putting in integers or numbers. So it starts off by saying integer type, and we'll call the array champ years, and because it's going to be championship years. And we have the straight brackets there, and we need to now, in the straight brackets, we need to put in the number of elements. And so we go from 0 to 5. So there's 6 elements. We'll say 6 elements here. And there you have it. That's your basic array declaration. What this is telling the compiler is that we're going to have a 6-element list of integers that we're going to refer to as champ years. So the compiler knows to give us enough memory for 6 integers, right? And so as we discussed before, integers take up 4 bytes of memory. And so the compiler is going to give us 24 bytes of memory. And so how an integer or how an array works is that it stores the elements of the array contiguously, meaning side by side in a list. So it has a solid block of 6 4-byte slots, you can think of it as. So there's a slot for the first one, a slot for the second one, and a pointer that points to the first, second, third, and so on as we go through the array. And they're all next to each other. So how do we fill in our elements for the array? There's a couple ways. And the first way that I'm going to show you is the longer way, but it's a little bit more thorough for our explanation. So what we can do is we can access champ years, and we'll give it the 0 index, right? So if we look up at our example here, our 0 index is our first index. And if you can think of it in terms of memory, we have 0, 1, 2, 3 kind of going along in a line. So our first index here, we're going to assign to 1991. So that's our first element. Then we go and we can access our second element, and we can assign it 1992, and with a semicolon. Champ years 3, 1993. We can go just kind of onward like this and just fill in our elements. Go to the fifth element in the array. And finally, we'll get our last one. So there you have it. That is how you assign elements in an array. And these work sort of like normal variables, where if you access the element using the index here, later on in the program, you can change this value. So there's no rule that you can't change it. And what you need to be cautious of is not going outside of the bounds of the array. Because remember, we have, 24 bytes for this particular array, and it's all in a line, right? Or they're in contiguous connected blocks. So it's 4, 4, 4, 4. So if you try to access champ years and we have 6, you're going to run into issues because you're outside of the bounds of the array. Remember, this is our 6th element, so you're accessing a second element or 7th element. We only have memory for 6. So once you go outside of those bounds, you'll just access whatever's in that memory location. So you have to be careful when you're doing that. Now we have our array filled in, and we can print our array. But what I'd also like to do is I want to print out the array size. So I'm going to use our size of method here just to show you that our array is actually the size that I've told you. So I'm going to compile this. We'll run our executable, and you can see down here our array is 24 bytes. So it's 24 bytes, which is 6 elements of 4. So 6 times 4 is 24. So we know our size. Awesome. We know our size, and we know that this is how you add elements to an array. What you can also do is you can fill in, this is the easier way, you can assign, a little shorthand here, you can just pass in your elements in a list here. So this is another way that you can add elements to your array. There you have it. This is passing in your elements this way is the faster version, of more, is equivalent to what we did down here. I just wanted to do this one first to show you that you can access each element individually using the index, which you can do to assign elements or change elements, whatever you want to do. Both ways work. Awesome. And so one thing that I want to point out is when you create an array this way, you are creating an array on the stack. So it's a very fast way to create an array. It's very efficient, but you are creating it on the stack. You can also create an array on the heap as well. Okay, and to do that, all we need to do is I'm going to get rid of our initializer here. I'm actually going to comment these back in. I'm going to get rid of our initializer list there. And all I'm going to do is I'm going to use the new keyword. I'm going to say int. I'm going to give it an array of 6 elements here and say that this is what we want to start off with. So what I'm going to do too is I'm going to delete this and make this a pointer, because the new keyword returns a pointer. Otherwise, everything else works the same. It's just this syntax creates an array on the heap. Now you'll notice, I'm going to run this code again, and you'll notice that the size of the array is actually the same. But when I go to print out, if I compile our new code and print this out, you'll notice that the array measures as 8 bytes now. The reason that it's measuring as 8 bytes is because we're printing out the size of the pointer, not the size of the array. And a pointer is the memory that a pointer takes up is equivalent to 1 word, and I'm using a 64-bit system, so 1 word in a 64-bit system is 8 bytes. It's printing out 8 bytes as the size of the pointer. However, this array is taking up the same amount of memory on the heap as it did the stack. It's just that we're printing out the size of the pointer here. So yeah, that's our introduction to arrays. I think that you should generally create an array on the stack. It's just more efficient. And I think that you should always keep efficiency in mind, especially when you're coding in C++, because that's one of the big benefits of using C++ is efficiency. So once again, an array is a collection of elements identified by an index. This is sort of a conceptual view of an array. This is the C++ syntax of this concept. And this is just to prove that the size of it. What you can do also when you're printing out things is you can access the element here. And if we, copy this line a couple more times, I'll print a few of these elements out. I want to print all of them out just because it'll just get repetitive, but just to show you that you can print them all out. I'll print these guys out. Oh, I'll do an end line for each one. Oh, sorry. End line here. And we'll compile our new code down here and run our executable. And as you can see, each element is 4 bytes. And if I wanted to access the actual element, I take off our size of method, remove that, and now let's print out the value of each element. Compile the new code, run the executable, and you can see we're now accessing our elements here. So, okay, there's one last thing that I wanted to mention here. And so we talked about the stack implementation of an array, which is illustrated here. We also talked about our heap implementation. Let's switch back to our heap implementation really quick. So I'm going to change this variable into a pointer like this. And I'm going to assign this pointer to the new array memory location. And everything's the same here, right? So now, though, we've implemented a pointer to the heap. The heap memory allocation and deallocation works differently than the stack. So whereas the stack is last in, first out, like a stack of trays, and that's dictated by scope, and it's automatic. So once you leave a scope, all of the variables that you've allocated onto the stack for that scope get deleted. With the heap and with this type of pointer that we're using here, it's manual. So we've manually allocated the array onto the heap. Now we have to manually delete it from the heap. So to do that, we use the delete keyword. We say an integer array called, sorry, it's not an integer array, just an array called champ_years. And that should do it. So let's run our program here, run it. Function's the same, except this time when we ran it, we deleted our array off of the heap. So this is one of the things that is a little bit more tricky about C++. When you're using a pointer and you're allocating memory onto the heap, you have to remember to deallocate it or to delete it from the heap when you're done. There is a way around this using smart pointers, but for the sake of our class here, we're not going to be using those. We're going to be doing everything manually. Okay, so this wraps up our tutorial on C++. We saw what an array is, what an index is. An index is just a number that you use to access a slot in the array. Once you've accessed that slot, you can fill it with a variable. We can access those variables by using the index. We can We learned how to allocate an array on the stack. We learned how to allocate an array on the heap. When you allocate an array on the heap, we learned how to delete things off the heap as well. So there's a lot kind of packed into this little tutorial. I hope you learned something. Thanks.